Today, the lesson is going to be about rotations. So, we have already done a section on reflections. We've already done a section on translations. So, a rotation is a transformation that turns a figure around a fixed point. Now, that point is called your, again, math people are not creative, point of rotation. Okay. Now, the question that this asks you is a rotation an isometry? So, if you guys reflect back to the very first day, an isometry does not change the shape or size of a figure. So, if we think about a rotation, it doesn't change the shape or size of the figure, it just changes the location of the figure. And so, yes, a rotation is considered an isometry. Now, what we've done here, describe the rotation from the pre image to the image, be as specific as possible. In years past, we have actually taught you guys how to do these rotations. But what we're going to do to condense time just a little bit, since we are kind of on a different schedule this year, is I'm going to just ask that you learn to describe the rotation. So, for example, what I want for you guys to think about first is which one is the pre-image and which one is the image. And the way that you know this is if you look at, like, say, C and C prime, or even B and B prime, or A and A prime, it doesn't matter. The primes are your image. This is your final point or your final triangle, right? I'm going to put it actually in here. And then this one is your pre. And the reason we know that is because of those, again, those primes. That tells you that's your final one. So the way that we're going to think about this is, first off, if we go from here to here, we know that our direction is clockwise. Okay. If it was going the other way, it would be counterclockwise. So we have it's clockwise. And then we want to tell how many degrees. And this is the part where for some of us, it might be a little bit of a challenge. So you want to pick the same or the point and its pre-image. So you want to pick like A and A prime, or B and B prime, and C and C prime. And what you want to do is you want to connect A to that point of rotation. And I'm actually going to be a little OCD here and make this perfect. And then I want to connect my point of rotation to my new A. Okay. And what I've created there is an angle. And that angle obviously is obtuse. But what we're going to do is we're going to drop in a protractor. And this is not a major point of the lesson. So don't like freak out at home, especially if you don't have a protractor. I just kind of want to walk you through this a little bit so you can see how this is done. All right. So what we would do is we would take the middle of the protractor. So this little point right here in the middle where that little T is, and we're going to line that up with that point of rotation. We're going to line up the base of that protractor with one side of the angle. Now, again, we know it is a obtuse angle, or it's an obtuse angle. So as we look at this line over here, oops, I was trying to circle on the protractor, wouldn't let me. But over here goes through 60 and 120. Now, because it's an obtuse angle, we know 120 degrees is our answer. So we would pick both a direction and an amount. Okay, the direction and the amount. That's really all we're going to do with the ones without a coordinate plane, is look at how to identify the type of rotation that's going on. So direction and amount. The ones that we're going to spend a little more time on are these questions here. So we want to rotate JKL with vertices 2, 2, 4, -5, and -1, -6, 180 degrees. So this is what I would recommend. First and foremost, let's plot the points that they give us. So we have 2, 2, we've got 4, -5, and -1, -6. This looks a little bit better than that triangle that we did the other day. So we have J, K, and L. And we're rotating 180 degrees around the origin. Now, the best way to go about doing this, in my opinion, is literally you're going to take and rotate your piece of paper. And so what I mean by that is, when we look at this, let me actually back out of this for 1 second. I just want to actually get the whole thing. I'm going to take, now obviously I cannot rotate my smartboard, especially for you guys to be able to visually see what's happening. So I'm just going to make this a little bit smaller. And what I would do is I would pretend that this is my piece of paper. Okay. I'm going to turn this 180 degrees. So I'm going to turn it all the way around. And I'm going to take a look at my new points as if they were my original points. Okay. So you might want to grab a, like a Post-it or something like that. And I would say, okay, my new J prime based on this is to the left 2, down 2. So all I'm doing is going left 2, down 2, and I'm reading that point. And then I would say, okay, what about my new K? And my new K, I've gone left 4 and up 5. And so I've gone left 4 and up 5. And my new L, as I look at this, is over 1, up 6. And so those are my new points based on this picture over here. And so then what I would do is I would come back to my original. Again, think about writing this like on a scratch piece of paper or a Post-it or something. And I would just plot those points. -2, -2, -4, 5, and 1, +6. And that, I graphed something off. What did I graph off? Oops, sorry. I went up 2 instead of down 2. There we go. The reason I knew that was off is because it would look like a different triangle. Okay, so that's a good little teaching moment, even in the midst of my mistake. Um, if your triangle that you end with doesn't look like the triangle that you started with, you know you did something wrong. So we've got that triangle, which is the rotation of the original triangle. Okay. Now notice at the bottom it says, is there any pattern that you notice about the coordinates? So what I'm going to do is I'm going to take my original J and just write it down here. My original J was 2, 2. My original K was 4, -5. And my original L was -1, -6. So as we look at this, from here to here, what happened to your X and Y? Hopefully, you're recognizing that your original XY, they stay in the same location, but they just change signs, okay? Same thing here to here. They should stay in the original location. They just change signs, and I didn't write that second one. So your X and Y goes to opposite of X, opposite of Y. And then you're going to do the same thing. Now, notice though here, it says that we are rotating 90 degrees counterclockwise about the origin. So the first thing that I want to do is I'm going to take, again, I don't have a piece of paper to be able to spin easily, but I'm going to recommend that you do this so you can see it a little bit easier. You're going to take your paper and you're going to spin it 90 degrees in this direction it asks, counterclockwise. So we are going this way. Okay, so you're just following the direction that they tell you. So 90 degrees counterclockwise will take you right about there. And now I'm going to pretend that um, this new graph there on the left is going to be my new points. So I'm going to take a look. C, my new C is to the right 2 and up 5. Okay, right 2 and up 5 to get that guy. My new B is right 2 down 4. And my new A, if I look all the way over here, is to the left 7 down 7. Okay, and then I would come over here to my original and I would plot those points. So I'm going +2, +5 is my new C, +2, -4 is my new B, and last but not least, we have -7, -7 for my new A. And so this is my triangle that's been rotated 90 degrees counterclockwise. And again, if you notice at the bottom of this, it actually asks you again, is there any pattern you notice about the coordinates? So as you look at this, let's take a look. Sorry for that little bump. My original C was at 5, -2. My original B was at -4, -4, -2. And my original A was at -7, +7. So if we look here, I'm going to ask you what happened. So hopefully you're recognizing that your XY, okay, notice the X and the Y change locations. So I'm going to start with that. My X and my Y change locations, but then my original X value turned opposite. So it turned from positive X to the opposite of X. Notice it's not always turning negative, it's opposite. So if it had started negative, it would then turn positive. Okay. Now notice this last bit. What if you were asked to rotate ABC by 90 degrees clockwise about the origin? How would you approach doing this? So what I want for you to do is I want for you to take a minute. I want for you to go ahead and go back to that original example. I want you to go ahead and rotate those points 90 degrees clockwise about the origin. Give me what are your new points, and then also what, if any, did you notice about your coordinates? Okay. So hopefully that all makes sense. Please let me know if you have questions, especially if for some reason you're having troubles graphing. That is key when we're looking at all of these things. Okay. So please let me know how I can help. We're going to answer those questions. I'm going to give you some feedback. Thanks.